So what's going on YouTube? Today we'll explore how modern network detection and the response system identify potential threats using behavioral analysis and scoring mechanisms. We'll start with one of the fundamental building blocks, time-based detection. Now, before we dive in, it's important to mention that the video is intended for educational purposes. The example code we'll be showing is simplified to illustrate the core concepts. In a real-world NDR environment, time-based detection will be integrated with many other techniques and will involve more complex logic and tuning. While Kerberoasting itself can occur at any time, attackers often utilize the cracked Kerberos tickets during off-business hours, including late nights, early mornings, and weekends. This post-exploitation activity is a key focus of our time-based detection strategy. First, we import the necessary libraries, datetime for handling timestamps, and Scapy all for packet manipulation. Then, we load our packet capture file using LDAP pcap. Scapy tells us how many packets it loaded. Now, we loop through each packet in the capture. We are only interested in IP packets, so we check if the IP layer is present. If it is, we extract the packet's timestamp using pkt time. This is a Unix timestamp, so we convert it to a human-readable datetime object using datetime from timestamp. We then print the packet time. Next, we extract the weekday and the hour from the datetime object. This is what we will use to determine if the packet was captured during business hours. Finally, we evaluate if the packet was captured on the weekend or outside of our defined business hours. We then print these Boolean values along with the source and destination IP addresses. This information helps us correlate the time of the packet with the source and destination of the traffic. Now, let's run the code. You can see the output here. For each IP packet, we see the timestamp, weekday, hour, and whether it was captured on the weekend or outside business hours. This demonstrates how we can use Scapy to analyze packet timestamps and implement our time-based detection logic. Looking at our previous code, we can see that it's not very efficient for analyzing patterns across multiple packets. We need a better way to compare and verify packet timing patterns at once. This is where Pandas comes in. It's a Python library that allows us to perform vectorized operations on our packet data, analyzing all of it at once instead of one packet at a time. In our case, we'll use it to organize our packet data into a structured format called data frame that makes it easy to perform statistical analysis and identify patterns in network traffic. This will be particularly useful when we want to analyze the distribution of traffic between business and non-business hours. We start by importing necessary libraries, Pandas for data analysis, Scapy for packet manipulation, and datetime for working with timestamps. We then define a function called isBusinessHours. This function takes a datetime object as input and returns true if it falls within our defined business hours and false otherwise. It checks if the day is a weekend and if the hour is outside the 9 to 6 range. Next, we use LDAP pcap from Scapy to read a packet capture file. We then create an empty list called data. We iterate through each packet in the capture. For packets containing an IP layer, we extract the timestamp, convert it to a datetime object, and add a dictionary to our data list. Each dictionary contains a timestamp, business hours status, source IP, and destination IP. This creates a structured dataset from our packet information. Now, the power of Pandas comes in. We create a data frame from our data list. A data frame is like a table that makes it easy to analyze data. Then, we print the entire data frame so we can see all the packet information. Finally, we use group by to get a count of packets inside and outside business hours. This gives us a quick statistical overview. As you can see, we have a table showing each packet's timestamp, whether it was captured during business hours, and its source and destination IPs. Below that, we have the statistics showing how many packets were captured during and outside of business hours. This clearly demonstrates how we can use Scapy and Pandas together to analyze network traffic based on time. So, as we've seen, by combining Scapy's packet capture capabilities with Pandas' powerful data analysis tools, we can effectively implement time-based detection. This simple yet effective technique demonstrates a core principle of NDR, using behavioral analysis to detect threats. While this is just one piece of the puzzle, it's a crucial first step. By understanding when activity occurs, we can significantly narrow down our focus and prioritize investigations. In the next video, we'll dive into the actual content of the network packets, specifically focusing on LDAP traffic. We'll use Scapy to dissect LDAP queries and identify suspicious patterns that are strongly indicative of Kerberoasting attempts, such as requests for specific user attributes like a user account control or service principal name. We'll also look for unusual search scopes that could suggest malicious enumeration. Thanks for watching. Please leave your questions and comments below. I'd love to hear from you.